What is big data? Big data is used to define huge data sets which are larger than commonly used software nowadays. From this definition, you can understand already that it is a constantly moving target, which means that the data is always ever growing and software always comes behind, which also means that if you want to analyze data, visualize data, then current data sets are always larger than the abilities of software. Now, it is easy to look at the difference between big data and small data using the model of 4 V's, which are volume, that it's typically very much larger than currently used data sets, velocity, which means that it changes. It can be streaming data, it's ever-changing, and the variety, which means that it can come from different sources. So not only one table, and even not only one type of data source, but from many different types of data, many different types of structures, and even information can come from videos, and very many different data sources. And the largest of those 4 V's is veracity, which means that not every piece of data is usable and trustable similarly to others. So you have to be able to fuse together the data which is maybe which contains uncertain data together with facts. But this is a situation which you actually cannot avoid in nowadays situations. Big data is very often connected to data science, to data mining, and knowledge discovered from databases. And the process for that is that you start from data, then you select some data, you will do some pre-processing for that, then you will transform the data, you will apply the different data mining models for that, and then comes the most interesting and important part. You have to give your interpretation to the data, and you have to tell the story so that in the end somebody would take some action. And if we want to understand the trends of big data and data science in the best way, there is an interesting term coined by Berkeley and Stanford professor Andreas Weigand, which is social data revolution. And it uses different waves of changes in the analysis of data. And for example, first wave of changes is that if initially we wanted to analyze the data, then we first thought about the question, we formulated the hypothesis, then we started to collect the data, and then we started to analyze the data and to visualize it and to make some decisions. Now data is everywhere, which means that you have to put together pieces of different data and actually make sense of the data. So, and it's also sometimes called secondary data. For example, if one data was originally used just for security purposes, for access purposes, if you enter the building, your name was logged, your time was logged when you entered the building. And secondly, for example, if you go to a cafeteria, buy a coffee, it was just used for bookkeeping and for sales. But now it is only up to your imagination if you want to combine, for example, the access data, which comes from people's movement in buildings, and the sales data in a point of sale system, for example, in a cafeteria, to start to find patterns in data. For example, that one person, for example, Innar, every morning, 9 a.m., goes to, when he enters building, always buys coffee. This was something for which the data was already there, but it was only the imagination of the person which enabled to put those two things together and start to see the patterns. So the first initial classical way to analyze data was to form hypotheses and then perform the analysis. Second wave was to analyze the data which is already there, to analyze the secondary data and to make sense of that. And then the next wave was that people started to push new information to web. For example, in Twitter or in Facebook, they're typing that I'm currently happy, or I'm hungry, I want to go out tonight, or something like that. And you can actually use all that data, which is there's a term, social data, used for that, to put that together with everything else to find patterns or insights or sentiments from that data. Another way to look at it is that originally you used to have first a problem. You defined the problem, then you chose a model. You took data, you performed the analysis, and then you saw the results. Now it's actually everything can start from data. You can browse the data to formulate the hypothesis which you want to analyze. Or even you can find the problem which you want to analyze from the data, even if you have just a hunch, and then you want to go inside that data and dig it even deeper. And then you can do the analysis, and then you have to present the results. And what are actually then those analytical tasks which people are doing with the data? So whenever we talk about small data or big data, then we can think about different analytical tasks which people want to do with that data. And there's a great framework provided by Amar, Egan, and Stasko, which actually limits the list of different analytical tasks which you're doing. For example, you would like to find some values or actual answers. You would like to filter the data. You would want to compute derived value. You would want to find some extreme values from the data. You would like to sort the data, determine the range, find anomalies, find clusters, groupings, and find correlations between data. And using that kind of framework, it's actually possible to compare which software packages allow you to do that. And the data, as was mentioned before, is not limited only to tables. The data can now come from everywhere, even documents, legal text, or videos. And it is also very important to understand that every analysis or every sense-making of data must end as a presentation. And a very good framework for sense-making is actually provided by Piroli and Card, who then defines the steps as following. First, you will gather all the external data sources. Secondly, you will search and filter that data. Next, you would like to see how that piece of data which you find relates to everything else. So you would like to find different relations. And now, if you start to formulate already some hypotheses or insights from the data, you would like to find some extra evidence. And eventually, you have to tell the story of what you see in the data. Because otherwise, if you don't tell the story about the patterns that you find, no action will be taken. So that was a very short introduction to big data topics. Thank you for listening.